What we're going to be looking at in this lecture is ways to express concentration, and specifically two very common ways in which concentration is expressed in chemistry courses. So there are multiple ways to express concentration. Some of them are more commonly used than others, but generically speaking, concentration is just the amount of solute dissolved in a specific solvent. Okay, and that is what gives us our solution. Okay, so different ways of describing concentration are seen here. We have percent by mass, percent by volume, parts per million, and parts per billion, molarity and molality. So all of these are valid means of expressing concentration. However, the most commonly used concentration measurements or expressions in chemistry are molarity and molality. And this is what we're going to focus on for the remainder of the lesson. Molarity is one of the most commonly used measurements for the concentration of a specific solution. And molarity is actually calculated by taking the moles of solute and dividing it by the total volume of the solution in liters. Molarity is going to be represented by a capital M. So if I have a 1.6 molar solution of, let's say, sodium chloride, what that means is that I have 1.6 moles of NaCl solute dissolved in 1 liter of my solution. Okay, now obviously that relationship or that ratio that we have here needs to be consistently applied in any volume of solution. But we'll look at those details a little bit later. So basically, molarity is the moles of solute divided by total volume of solution in liters. So let's go ahead and look at a calculation here. In this situation, they've given us basically some information that will allow us to calculate our molarity. So they tell us that if we dissolve 0.440 grams of KSCN in enough water to make 340 milliliters of solution, what is the total molarity of this solution? Okay, so first of all, they've told us that we are calculating for molarity. So molarity is going to equal moles of solute divided by the total volume of the solution in liters. Okay, all right, so what we need to do is we need to first decide which substance that they've provided is our solute and which one is our solvent. Okay, so now notice here they've told us that if we dissolve 0.440 grams of KSCN, remember that the solute is the thing that gets dissolved. The solvent is the thing that is doing the dissolving. So in this situation, the thing that's dissolved is the KSCN, so it's our solute, and the thing that's doing the dissolving, the water, is our solvent. Okay, so as we progress through this, we want to continue and write out our substances. So our solute is 0.440 grams of KSCN. So that's our solute. Now, if we come over here and look at our equation, we notice that our solute needs to be in moles. Okay, so this is just going to be a simple, straightforward calculation that you guys have been doing, going from grams to moles, utilizing our molar mass. So we'll just set this up here. Okay, and we need to calculate our molar mass of our KSCN, okay, which is 197.181 grams for every 1 mole of KSCN. Okay, and we're going to go ahead and carry this calculation through. Okay, this is going to give us 0.002231 moles of KSCN. Okay, and that's going to have 3 sig figs. I'm going to mark that number because I'm not going to do any rounding till the end. Okay, and then our total volume of our solution is what we need to know next. Okay, well, our grams of KSCN aren't going to change our volume. So we go ahead and look at the next best thing in terms of what is going to provide the volume of our solution. So in this case, what they've done is they've told us that we are going to make a solution that has 340 milliliters. Okay, so basically we're going to take this KSCN solid and dissolve it into enough water to make a 340 milliliter solution. Okay, well, since KSCN isn't going to be contributing to the volume, our 340 milliliters must be coming from our water. Okay, so what we're going to now do is look at our solution and look at the units we're supposed to have. Now, the volume of solution needs to be in liters. So they have given us 340 milliliters. Okay, so if we move that decimal over, we're going to have 0.34 liters of our solution. Okay, so now in order to calculate molarity, I'm going to take the moles of solute and divide it by the volume of my solution. So 0.002231 moles divided by 0.34 liters. Okay, and if we go ahead and plug that into our calculator, this is going to give us 0.00656 m. Okay, so molar. All right, so what do we have here? We have basically this concentration of our KSCN when we dissolve 0.440 grams of the KSCN into basically 340 milliliters of water. Okay, so this is our calculation for molarity, pretty straightforward. Now the next thing we're going to look at is molality, and molality is another way of expressing concentration. Okay, but notice that it's a little bit different than the molarity calculation that we just did. Okay, so first of all, molality is similar to molarity in the fact that the solute must be in moles. Okay, so that's the commonality there. Now, molality, though, is calculated using the kilograms of solvent as my denominator. Okay, so in the situation when it says kilograms of solvent, it is meaning the mass of the solvent only. Okay, so if we're mixing, let's say, ethanol, which is a liquid, and water, okay, and water being my solvent, the reality of it is that I'm not going to calculate in the mass of the ethanol. I'm only going to calculate the mass of the water because that's my solvent. Right now, in order to figure out our mass of our solvent, we're going to need to know our density values. Okay, so what do I mean by that? Okay, well, we know that the density of water, for instance, okay, is equal to 1 gram for every 1 milliliter. Okay, so if I have 10 grams of water, then I'm going to have 10 milliliters of water. Now, any solvent is going to have its own specific density, so if the solvent is not water, then you would have to either look up its density or I would have to provide it in order for you to convert between milliliters or volume and mass, such as grams. Okay, and once we get in our units into grams, of course we want to be in kilograms, so we're just going to move our decimal over in order to make that happen. So let's go. So one more thing I also want to point out is the units that are used to express molality. Okay, molality is represented by a little lowercase m, as you see here. Okay, so a 0.25 molal solution that we see here is represented as being molal because of this lowercase m. So that allows you to differentiate between molarity and molality, so make sure you're paying attention to those details. So in this problem, they told us that they want us to find the molality of a solution containing 75 grams of magnesium chloride in 250 milliliters of water. Okay, so in this situation, guys, I have my solute, right? And I have my solvent. Okay, so in this situation, guys, they have given me this information. The reason why I know that this one is my solute instead of this one is because my solvent is present in a greater quantity. And so basically this allows me to set up my molality calculation. Okay, so molality, remember, is equal to moles of my solute divided by the kilograms of my solvent. Okay, and that's what we see right here. Okay, now we need to make the math happen so that we can go ahead and proceed. Okay, so the first thing we're going to need to do here is obviously convert our 75 milligrams into the, our 75 grams of magnesium chloride into moles of solute. Okay, so we have 75 grams of MgCl2. Okay, and we need to move this or convert this into moles of solute. Okay, so we're going to have our grams and our moles down here, just like we've done in the past. Okay, and so we get our molar mass, 95.211, okay, per 1 mole, and this is going to give us our moles of our MgCl2. Okay, and so that is equal to 0.7877. Okay, it's going to end up having 2 sig figs, but we'll address that later. So this is moles of MgCl2. Okay, now I want my molarity, so remember I need to be in kilograms of solvent. Okay, so they've given me 250 milliliters of water. Okay, well, obviously I need to go from a volume measurement to a mass measurement. Okay, and so in order to do that, first thing I need to do is convert my milliliters of water into grams. Okay, and I know that the relationship between my mass and my volume of a substance is the density value. Okay, and I know that for every 1 gram of water, that's going to be equal to 1 milliliter. Okay, so 250 milliliters is going to equal 250 grams. Now, I don't want to be in grams, I want to be in kilograms, right? Okay, so in order to go from grams to kilograms, I need to move my decimal, okay? And when I do that, I'm going to end up with 0.25 kilograms, okay? Now, I have my denominator, I have my numerator, so now we're going to plug everything in. So 0.7877, okay? That's going to be divided by 0.25 kilograms. Okay, we plug this into our calculator. This gives us 3.15 molal. Okay, and with the appropriate number of sig figs, which is 2, we end up with 3.2 molal solution of magnesium chloride. Okay, so in this situation, guys, they're asking us how many grams of sodium chloride are required to make a 1.54 molal solution using 0.500 grams of water. Okay, so they've told us how much water we are going to utilize in the solution. They've also told us their molality. Now, remember, our molality is equal to the moles of solute, which in this case would be NaCl, for every kilogram of solvent, which in this case is water. Okay, so this is our relationship. This is our molality situation, okay? Now, they want to figure out how many grams of sodium chloride I would need if I made a 5A solution using a half a kilogram of water. Okay, so in order to do that, I need to find out how many moles of NaCl would be in a solution with 1.54 molar concentration, but made with 500 kilograms of water. Okay, so what I'll do is I'll take my 500 kilograms of water, okay, all right, and I'm going to multiply it by my molality. Okay, so 1.54 moles of NaCl for every 1 kilogram of H2O. Okay, so basically kilograms of H2O are going to cancel. This calculation is going to give me my moles of NaCl. So this gives me 0.770 moles of NaCl. Okay, now they didn't ask me for moles of NaCl, they asked for me to give them grams of NaCl, so I need to take my moles of NaCl and convert it into grams. So I need my molar mass of NaCl. Okay, so I'm going to plug that in, okay, which is 58.44 grams for every 1 mole. Okay, so we do that calculation, and this gives us 44.99, okay, which to 3 significant figures is going to be 45.0 grams of NaCl. Okay, so this is just a way we can figure out how much of a specific solute or solvent we'll need in the molality calculations.